Hello and welcome to Relatable Code. In this video, we're going to talk about generics in Kotlin. So let's get started. Imagine a huge library with dedicated sections, from thrilling novels to dense academic writings, for example. While these books differ, the librarian's tasks like landing, cataloging, or restoring are uniform across all types. Okay? In programming, just as the librarian doesn't need a unique process for every genre, we avoid crafting multiple functions or classes for each data type thanks to generics. Generics in programming act as placeholders. They enable us to design a blueprint, like a class or a function, that can operate on various data types, like an integer, a string, or even custom types. Okay? Without knowing them upfront, which promotes code reusability. I'm going to show you how to define a generic function in Kotlin. Okay, let's start with a simple function called print book detail. This function will just print out whatever is passed to it as a parameter. Now, how do you define a generic parameter for a function? You do it like this. After the fun keyword, you open these brackets if you want, the less than and greater than signs. And here you pass a name for this generic. Okay, generics are most commonly used with the T word in programming. Okay, you have T, you have R, you have E and V, most commonly used for generics. But you can name them whatever you want. Okay, and here as a parameter, we can define value T like that. And inside our print line, we can print out book detail and value, just like that. Okay, so now whatever I pass to this function as a parameter will get printed out in this function. Let's test it out in the main function here. Let's say we want to print book detail for our custom book. Okay, let's run that function. And here you go. You have book detail, our custom book. You can also use this function with other types, which is why it's a generic function. You can use it like this, for example, with a book edition if you want, which can be an integer, like that. Let's try it out. And as you can see, this is our book detail with an integer. Okay, generics really allow you to be very flexible with your functions, which is why they're very helpful in programming. Okay. One nice thing you can do with generics in Kotlin is you can restrict them to certain types. Okay, so let's say I have an open class library item, and let's just comment out our code here so that we don't have any conflicts. Class book, which extends library item, like that, and class magazine, for example, which also extends our library item. You can have a generic be specific to this library item, like that. You can have it extend library item, and you can call it print library item details, value T, just like you would for a normal generic function. And now print library item details expects a generic value, but if I pass a string, I get an error because now I need a library item. Okay, so now I have to create either a book or a magazine for my example. Let's just have these be data classes. Okay, val book name, and here val magazine name, also extending a string. And here you can just pass book name if you want, just so you can see when I run my function. It will also display my book detail as I've specified. Okay, this feature will be very useful in our coding journey. You can also work with generics and classes in Kotlin. So you can define a class like this library shelf, for example, but with classes, you have to specify this T generic after the name of the class. Meanwhile, with functions, you have to specify it after the fun keyword. Okay? So with classes, this is how you create a generic class. And inside this generic class, we just have a bunch of items that are of this generic type, initialized to an empty list. And we have an add item function, which basically adds a generic item to our items list. It also has a function that removes an item from that list, also taking a generic item as a parameter. In addition, you also have a function called display items, which just displays these items with a println function. Okay. If you check the main method now, you can see that I've created a bookshelf like that with a string type. And I used it like this. I added an item to this bookshelf, which was the name of a book, and another book here. And in the end, I displayed these items with the display items function. I did the same for an integer type for this library shelf, okay, where I could add integers and display them as well. And I did this with the library shelf example because I wanted to simulate that a library shelf may hold different types of items. Okay, they may hold different types of books, magazines, or whatever you want in your application. So if I run my main function now, I can get these two strings and these two integers. Okay. Now I'm going to show you one of the true powers of generics. I'm going to define a function that returns the first item in our list. Okay. Let's call it get first item. It's going to return a generic, which is basically a single item from our list. And we're going to do it like this. Items dot first, like that. And now, in my main function, let's say I want to access the first book in my bookshelf. I can write val first book equals to bookshelf dot get first item. And as you can see, get first item in this instance is a string, okay? Because our bookshelf is a library shelf of strings. Meanwhile, if I try to do the same for my DVD shelf with first DVD, I can write DVD shelf.get first item, and here get first item is now returning an integer, okay, because our DVD shelf is a library shelf of integers. And this is a true power of generics, because you don't have to check this type at runtime. You have access to this type actually at compile time. So you know that this first book will be a string because this bookshelf is a library shelf of strings. And the same goes for DVDs. Your DVD shelf is a library shelf of integers. Okay, so your first DVD will for sure be an integer. Okay, this gives you the type safety at compile time actually, which can save you from a lot of errors. Okay, so now you don't actually have to check if first DVD is an instance of an integer, for example. You just have direct access to the type of first DVD as soon as you write DVD shelf dot get first item. Okay? Sometimes we're only concerned about reading from a collection, but not about its exact type. Okay, it's like knowing you have a list of books, but you're not certain about a specific category of books that you're dealing with. And this is where you use the star projection, which is provided in Kotlin. This is like saying you have a bookshelf which contains a list of things that you don't know about. Okay, so this is how you define a function called print first that has this list as its type. Okay, and inside the implementation of this function, you have if the bookshelf is not empty, you're basically just printing out the first item in this bookshelf. Okay, so in my main method, if I want to use it, I can write print first with pretty much anything that I want. Okay, it has to be a list, of course. It can be a list of strings, for example, like this. First string, second string. If I run my function, I get first string because that's the first element in my function. Well, what if I replace the star with the any keyword that we know of already? What does it differ from the star projection? Well, with the any keyword, you can't define any nullable types. So if you have a list of null, for example, if for any reason you're trying to retrieve a list from your server and this list is null, you can't work with it like that. Okay? But when you use the star projection like that, you can normally work with nullable types. So if I run my function, I get null. Okay? So in certain cases, you will need to use this star projection provided by Kotlin to really make your work easier. Okay? And now we're going to dive into a complex topic in generics, and that's covariance and contravariance. Okay, so really focus on what I'm going to say. It's okay if you don't get it the first time. You can rewind this part and watch it again. It's not an easy part, but when you grasp it, you will really appreciate generics and how they're made. Okay, so we're going to start with covariances, and I'm going to let you imagine that we have a shelf. Okay, let's say it's a fruit shelf, and it's designed to display a specific type of fruit. If this shelf is designed for an apple, it's perfectly fine to use it for a specific kind of apple. Let's say a Granny Smith apple, for example. Okay, this is because a Granny Smith is a type of apple. And this is the idea behind covariance in Kotlin. A shelf meant for a general item, like any apple, can be used for a specific version of that item, like a Granny Smith apple, because you only care about displaying that item, or in other words, producing that item. Now take a look at this shelf class. We have a class shelf, and it has a generic parameter, but this generic parameter is now defined with the out keyword. Okay, this out is used for covariance, and it expects an item, which is of this generic type, and it has a function that returns this item. Okay, so when you use this out keyword, you have to produce this item. You can't consume it, which means that you have to always return it. So you can't have it as a parameter for any function inside this class. Okay, so if I try to do something like val input of type t like that, I can't do that, okay, because this t is declared as an out, but it occurs as an in for this position. So you can't use it for an input, you can only use it as an output, okay? So when you use the out keyword, like in our shelf class, it means that the class is covariant in that type parameter. It's safe to produce or return that type, like getItem does, but not to consume it or accept it as an input. You can safely read items of type T from it. Okay? And now, for the contravariant types in generics. Let's say we have a specialist doctor, like a pediatrician, for example, which is a children's doctor. A pediatrician can treat all children, from infants to teenagers. Okay? Let's say you want to visit such a pediatrician, but he is not currently working. Let's say he is on vacation. Instead, you have a general family doctor who can treat people of all ages, basically, not just children. So if you have a function that needs a doctor for a teenager, for example, you can pass in a pediatrician because they specialize in treating kids, but you could also pass in a family doctor because they can treat people of all ages. Okay? This is the idea behind contravariance, where a function meant for a specific type, like a pediatrician, can be used with a more general version of that type, like a general family doctor. Okay? A general family doctor may perform the basic tasks that your child might need at that time. Okay? And that's if you want a basic example of contravariance. Now in our code, we don't have any doctors. We have input shelves here. So we have a class called input shelf. It takes a generic parameter, but this time it's marked with the n keyword. Okay? However, in this function, you have, or in this class, you have a function called putItem, which expects an item of this generic type as a parameter. Okay, and this works for generics with the n keyword, but keep in mind something. You can't have it return any value. In this case, you can't have it return this generic value, like that, for example. You get an error here because this type parameter t is declared as an in, but it occurs as an out position for this type. Okay, similar to what we had previously with this example, because out parameters are only expected to be returned by functions, whereas in parameters are only expected to be taken as parameters inside functions, or in types if you want, in generic types, are expected to be taken as input parameters for any functions. You can't produce these, and you can't consume out generic types in Kotlin generics. Okay? Now, I'm going to show you an example for both the covariance and the contravariance. Okay? So I have a function called display library item. It takes as a parameter a shelf of library items. Okay? Remember, our shelf was a covariant. So what happens in this function is just a simple println statement. Okay, with shelf.getItem, this getItem. And for our second function, we have a storebook on shelf. Okay, it also takes a shelf as a parameter and a book. But this shelf is an input shelf, which was this one, our contravariant input shelf. Okay, and it called the shelf.putItem function with this book. Remember, our covariants were primarily used to produce something, and our contravariants were used to take something as a parameter. Let's see these functions in action. So if I show you my main method, I only create two shelves, okay? I created a bookshelf with our covariant shelf, this one, taking a book as a type and having an initial value of shelf containing a book with this book. Okay, and we're calling this function display library item for this bookshelf. Okay, before moving on to the contravariant part, let's see what happens here. So we have a shelf. In this case, it was a shelf containing a book. Okay, with our function, we were dealing with the shelf that was the covariant. Okay, and with covariance, as you now know, you can really pass a library item or any of its subclasses. In our case, we passed a book. Okay, let's comment this out for now, and let's run our function. So here we have our book. It was printed out. So this code was invoked. What if, instead of my book, I had a magazine like that, and that was okay, because shelf expected an out covariant generic, and the way we were using it was in this function, was we had a shelf of a library item. Okay, so when you use it like that, you can use a library item or any of its subclasses. Meanwhile, with contravariance, like our input shelf, we created an input shelf with a book. Okay, and we called our function store book on shelf, which basically expected an input shelf of our book. Okay, and a book as well. So we passed these as the required parameters, and we can now comment out this one and run our function, and nothing will get printed out because we don't have a print line statement. We're only putting the book inside the shelf. Okay, what if I replaced this book with a library item? And as you can see, this works. But if I try to replace this library item now with a magazine, this doesn't work anymore. Okay, our function expects an input shelf of type book, and it worked with the library item because library item was a superclass of our book data class, and we were dealing with a contravariant. Okay, this was our contravariant. So with contravariants, you can work with a certain class. In our case, let's say this was a book, and its direct superclasses. Okay, so our input shelf here can be an input shelf of type book or of type library item. This doesn't produce an issue, even though our function expects an input shelf of type book. Okay, but because this was a contravariant, this was okay. But as you saw, when I replaced my library item with magazine, this was an issue because magazine was not a book and it was not a superclass of a book. Okay, I hope that explanation was clear. I tried to show you the difference between covariance and contravariance in this context. Okay, so with covariance, here you normally pass the supertype, like library item, so that you can use library item or you can use magazines or your books. Okay, because you care about the return type in that case, and as long as you pass the supertype, you're fine, because in that case, the return type can be a book or a magazine or a library item itself. Okay, and now we're going to talk about reified types in Kotlin. Imagine you're at a magical library Most of the books in this library are enchanted and can shapeshift into different forms. When these books are stored, they all transform into a general-looking book, which can't be distinguished from one another. Okay? This is similar to how the JVM sees generic types due to type erasure. It just sees them as generic objects without any specific type information, which happens at runtime. At runtime, any type of information about generics gets erased. Okay, this is what I mean by type erasure. Now say you're a librarian in this magical library, and you want to find a book that can turn into a mystery novel. If you pick a general-looking book from the shelf and you ask it, "Are you a mystery novel?" it won't be able to tell you. And that's a limitation, right? And that's where we need a magical magnifying glass in Kotlin, a special tool given to librarians. When you use this magic magnifying glass and you look at any book, it reveals its true nature, allowing you to see if it can be turned into a mystery novel or any other specific type of book, which you will need in this case. In Kotlin, this magic magnifying glass is the reified type, which we will now discuss in our code. Our example is actually not accurate. Let's replace this with any. Let's replace this with t. Let's erase this. Let's print out it's our generic type. And here we write other type. So what did we do here? We had an inline function. When you want to use reified types, you have to specify an inline function. Okay, if I erase the inline keyword, I can't use the reified type anymore. So I need this keyword. And I have a function called checkType, which basically takes any as a parameter. And inside this function, I am able to check if this item is of my generic type or of any other type. Okay, so in my main method, if I write checkType, and here I have string, and let's say I pass an integer to this function, what do I get? I get other type. But here, if I pass a string like that, I get it's our generic type. Okay, and this is very useful in many use cases, which you will see in the future, because it gives you the ability to check for any type if it's of a certain generic type which you're working with. Okay? Well, I couldn't help but show you a certain usage of the reified type because this is something that I really like to use and check for. Okay? So with the help of our reified type, let's say our any was a generic type of t in this case. Using the reified type, you can have access to t class.java. Okay, so now if I write it like that, can I erase the string? I can, because it's no longer expecting an any. And as you can see here, I had access to the generic type just like that. Okay, this couldn't be possible without the reified type, because if I delete this like that, as you can see, I can't access the class. Cannot use t as reified type parameter. It's telling me to use a class instead. Okay, and the suggestion here is make t reified and check type inline, just as we had earlier. Okay, and I can't tell you how useful this is. You will discover it in the future when we get more hands-on programming with Android. Okay? If you find this content to be relatable, please don't forget to leave a like and subscribe for future content, and I'll see you in the next video.